Hi guys. So it appears that several of you are having a hard time with Unit 4 Homework 4. So I'm going to try to make some sense out of the confidence intervals for you. So I did take a screenshot of the image that is in the Math and U textbook. And it says if a sample is randomly taken from a population, then the sample mean can be used to estimate the population mean given the following limitations. So you'll see there's a number line here. The red is the estimated population mean, the mean of the whole group. And then the margin of error goes from the mean out to the end of the confidence interval. So the wider the confidence interval, the larger the margin of error. The smaller the confidence interval, the smaller the margin of error. And what is that confidence interval? All a confidence interval is a range of values used to estimate the value of an unknown population. It's unrealistic to actually survey every single adult in the United States about their thoughts or feelings or opinions on an item. So, what you look for is a representative sample that is randomly chosen. You want to omit as many biases as possible. So when all of those conditions are met, then you can come up with your estimated population mean and you can come up with a confidence interval. And then it says the confidence level is the probability that the interval contains the population mean. Suppose a large number of different samples of the same size are collected, and a 90% confidence interval is created for each sample. It should be expected that 90% of those intervals will contain the true population mean. So I've also borrowed another image out of your textbook. So let's pretend that this is a sample size of 100. This is somebody else's sample size of 100. Another sample size of 100. Altogether, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different samples of 100 each. So the N, the quantity, the number in each sample size is 100. And then each person is going to get a sample statistic, a sample mean. The confidence interval at 90% means that 90% of all of those different sample means will contain the true population mean. So if we look at this little diagram here, 9 out of the 10 land on the true population mean, which is represented with that red line. So this red line represents the true population mean. These here have this is the mean of this sample, so all of these go back and forth. So some of these have a slightly larger, higher mean, some have a lower mean, some may be a little bit wider than others depending upon the standard deviation, how wide the variance of each sample is. Ideally, you want your sample sizes to be large enough so that there's not a lot of variance. So in this case, 9 out of 10 or 90% did contain the true population mean. That's what a 90% confidence interval means. 95 happens to be a very common range to use because two standard deviations contains 95% of the data. So if you think about those histograms that we had looked at earlier, one standard deviation away on both sides, it's about 68%. Two standard deviations away, from the mean above and below represents 95%, and 3 standard deviations away from the mean is 99.7%. One of the things that the Math and You book does have, it has a section of tools, and the tools came up in the book. I have put the link here for the one that does confidence interval calculator. So if you're going to use this one, I'm going to show you what it looks like, and hopefully it will come up. Oops, here it is. So this is from the Math and You book. It's the confidence interval calculator. And if you look, there's 90%, 95, 99, the three most common ones. In order to use this to give you the confidence interval, you need to know your sample size, your sample mean, and the sample standard deviation, and then it will do the calculations for you. So we're going to practice a few of those in a second. Let's go back to the worksheet. So here is an example taken from the Math and You book. This is a histogram that shows IQs of 50 adults, and we're going to use it for 2 questions. When I look at this, I know it's normally it's a normal distribution because it makes that nice bell curve. And I could count that there's 50 people. 2 plus 6 is 8, plus 7, and you just add these all up to the frequencies on the side, and you will get 50. And it has IQ levels in the 60 to 70 range, as well as high Q levels in the 130 to 140. Now, remember this. So here the standard deviation is saying that it is 18. In this sample size, 99 is the mean. So 99 minus 18 would be 1 standard deviation below. 99 plus 18 would be 1 standard deviation above. 99 minus 2 times 18 would be 2 standard deviations below. 99 plus 2 times 18 would be 2 standard deviations above. So that would give us an estimate of the 95% confidence interval just using twice the standard deviation. But this is telling us here, use the confidence interval calculator in Math and You and find the 95% level to estimate the population mean of the IQ scores. So I have to use the information here, the 99, the 18, and the 50. And it says 95% confidence interval. So now I'm going to go back and find that. Change this to 95. The sample size was 50. The sample mean was 99. And the sample standard deviation was 18. As soon as you put those in, notice the calculate button is now gray and I can click on it. We end up with a margin of error of 4.99, approximately 5, with a confidence interval of 94.1 to 103.9. So I may have to switch back and forth to get this written down. 94.1, 103.99. So I'm going to go here and I'm going to write 95% CI, whoops. And I'm going to open a set of parentheses for the low value so we can see what this looks like. Just go back to where we were. The low value is 94.1. The low value was 94.1. Going to use a comma to separate the upper value. The upper value was 103.99. 103.99. And the margin of error, the MOE, was 4.99. Now, this is one way we can write a confidence interval, but you probably have seen, well, how do you write this with the plus and minus? So on this case, I'm going to start with the mean, and the mean given here was 99. So it's going to be 99. Let me see if I can find the plus or minus symbol. I think it might be on the top up here. There it is, plus or minus symbol. And now I need the margin of error, 4.99. So the confidence and 95% confidence interval can be written out this way. It also can give us, we can write it this way. And this one I am going to highlight. The 99.49. So 99 minus 4.99 will equal the 94.1. And 99 plus 4.99 will equal 103.99. And question 2 says, well, what if we increase the sample size up to 100? So I'm going to still have a 95% confidence interval. So I'm going to start with that, CI. And it's still going to start with an open set of parentheses. But now I'm going to reset everything. You have to hit reset. And I'm going to change the number of people. Now, this only has 50, but I'm still going to use the 99 and the 18. So going back to this, I have to hit reset. We're leaving this at 95. We're changing our sample size to 100. 99, 18. As soon as I put the 18 in, notice how the word calculate will now get highlighted and I can click it in. Our margin of error has decreased. Our sample size has increased. Our margin of error has decreased. So the low value is 95.47. 95.47, comma. Our high value is 102.53. 102.53. Our MOE, our margin of error, is now, it's going to be less than that, 3.53. 3.53. So now we would write this as 99, the plus or minus, and the new margin of error is 3.53. I'm going to highlight this because I want to point these out. So let's look at what's happened here. Just by increasing the sample size, doubling it, we went from 50 to 100. Our confidence interval has shrunk some. It's gotten smaller. Instead of being up here 94, it's now 95. Instead of going all the way to 103, it's now going to 102.53. So by increasing the number of people sampled, the sample size, it's going to make the margin of error a little bit smaller, and it's going to increase the confidence interval. I want you to think about the reason why, but I'm going to end up telling you this. The more of a random sampling you can get, the larger the sample size. As long as it's done randomly and in the exact same way, the closer and closer you will get to the true population parameters. So the bigger the sample size, as long as you keep all the other parameters the same, the closer you're going to get to that true population mean. Let's look at the second example that I took from your book. This one is about the miles per gallon on a sedan. This one is not quite a bell shape. It seems to have a little bit of a tail on the right end, which this little tail is going to bring up the mean a little bit. The bulk of the cars have a mile per gallons down here, in this 20 to 23 range. But these few, and notice this is only one, this is one, two, one. These few will pull the mean up a little bit. Then they give us the frequency here. No place in the description does it tell us how many vehicles are in this survey. So we actually have to count 2 plus 3 plus 4 plus 9 plus 5 plus 3. When I counted this, and I did it through twice, I got 60. So I know that N equals 60. The number in the survey is 60. Did I put this picture on here twice? I think I did. Well, we definitely don't need it twice. Okay, so move that back down and go back up. So now it's saying the same thing. Use the calculator to get the 90% confidence level to estimate the population mean. Well, I need to have three things. I need a mean, I need a standard deviation, and I need to know the size of the sample. So we're looking for 90%. I'm going to go back to where that is at, hit reset. It automatically resets to 90. I know the sample size is 60 because I counted the number of vehicles represented on the graph. The mean, I believe, was 23.3. It is 23.3 with a 3.9 margin of error. So that means it could be within, each standard deviation is 3.9 miles per gallon away from the mean. So one standard deviation would be 23.3 plus 3.9 or 23.3 minus 3.9. Two standard deviations would be double this. So we're looking for the 90% confidence interval, calculate. So according to this, at 90%, where 90% of all samples will capture the true population mean, will land between 22.47 and 24.13. So 22.47 is our low. So for number 3, at a 90%, that's not a percent sign, I'm sorry, confidence interval, the low value will be 22.47 miles per gallon, 47. Use a comma to separate the low from the high, 24.13, 24.13. The margin of error they give us, MOE is what I use for margin of error. I was looking for shortcuts, and it's 0.83 miles per gallon. So 0.83 miles per gallon. So what this is saying is the margin of error to get from this side to this side. The mean would be 23.3. And then if I use a 90% confidence interval, our margin of error is 80.3. So to rewrite this with the plus and minus is 23.3 miles per gallon plus or minus, and then whatever we got for the margin of error, which is 0.83 miles per gallon. I hope this is starting to make some sense to you. And then the second question says, well, let's keep all the parameters the same, except let's go for a 99% confidence interval. So what we're doing is we're stretching that 90 all the way out to 99. So we're saying that we're with a 90% confidence interval, 90 samples, 90% of the samples will capture the true 99, the true population mean. But if we go to 99, we move it out to 99, we're going to say 99% of the confidence of the samples will include the true population means. So we should end up with a larger margin of error because we're stretching out. Let's see if that happens. So I have to hit reset and re-put in the 23.3 to 3.9 and change from 90 to 99. We can't just change it to 99. It won't let us, so we have to actually hit reset, drop it down to 99, and it was the 23.3. Sample size comes first, which was 60, 23.3. I think it was 3.9, but I'm going to double check before I hit. Yes, it was 3.9. Now I'm going to hit this. And the margin of error did go up to 1.3, which I hope you would expect. So now the interval goes from 22 to 24.6. So at the 99, whoops, I don't know what I just hit. At the 99% CI, our low value is going to go down some, and it did to 22. And our high value should go up some, 24.6, and it went up a little bit, 24.6. And our margin of error should get a little bit bigger. Margin of error equals, I know it was 1 point something, 1.3. So by increasing the margin of error, that is a result of increasing the 99% confidence interval. So we're taking in more spaces on both ends, and we would write this as, and I'm just going to be lazy now and just do Control C, Control V, because what's going to change is this is going to become 1.3. So let's see what happened. We went from a small confidence interval of 90 to a larger confidence interval of 99, which therefore increased the margin of error. Now, here's something interesting, and I don't know if you've thought about this, is what if I add these two and divide by 2? What if I add 22 plus 24.6, and this 2, so I'm getting the average, and divide that by 2, what will it equal? So what if I add 22 plus 24.6 and divide by 2? I should do the Desmos calculator, but this will come up a little faster. So I'm adding 22 plus 22. Now I can't remember what it was. Sorry. 24.6. So let's see if I could back that up one. Okay, I got to clear the whole thing. 22 plus 24.6 equals divide by 2 equals. Does that number sound familiar to you? 23.3. The 23.3 was our sample mean. Something to keep in mind as you do some other work. Another thing I want to look at with this is, so this gave us back the 23.3, which was the sample mean for, I'm just looking at the bottom one because it was easier. What if I take the 22 and add to it the margin of error 1.3, and hopefully you can see this. 22 plus 1.3 is 23.3. Isn't it interesting the way this works? Let me put a little more space so you can see this and space this out again here. What if I took the high number, the 24.6, and minus the MOE, 1.3? See what that equals. Well, 6 minus 3 is 3. 24 minus 1 is 23. 23.3. What do we notice here? So there's a lot of correlations with all of the pieces, working forward or backward, whatever you need to do. If I know the confidence interval and I get the difference, so let's take the first one, 24.13, 24.13, and minus from that 22.47. And I'm going to put all of that in here because I want to get the difference first. Whoops. I want to get what this difference is first. And then I'm going to divide that difference again by 2. So first I want to get the difference, 24.13. So clear everything out. 24.13 minus 22.47, 22.4 first. Did I copy these over right? 24.13, 22.47. Why am I getting 20.13? 24.13 minus 22.47, 22.47, enter. Oops, move my head up a little bit. That looks a lot better, 1.66. And then take that answer and divide it by 2. Whoops, I want the answer from above. 1.66 divide by 2, and there it is, 0.83. I'm not sure what was happening with the other calculator, but Desmos never steers me wrong. Woof, I was getting nervous there. So we do end up with, just want to make sure you see it. Where did I put it here? 0.83 comes back. So I just want to make sure you see that. Equals 0.83. So we can go forward and backwards. I'm so sorry. I don't know why this took so long. on the other calculator, but we should be able to go forward and backwards, and this will match the margin of error. Now, there were people who had some questions about, well, what do you do if you see something like this? So I just went to Dutchess County Statistics and I looked up the 2018. I tried to get the 2019 traffic violations and it would not come up. So I found the 2018 traffic violations. 71,671 traffic violations were issued. Of those, 22,433 was speeding tickets. Well, what is the sample statistic? So what you have to do for this is what you're going to put in the calculator is your part, 22,433, divide by the total amount, 71,671. That's a lot of tickets. And that's going to give you our sample proportion. So let's start with the 22,433. And I will go to Desmos this time, clear everything out, clear all. And I think I wrote that down so I would not forget it. And I wouldn't have to go back and forth. Maybe I didn't. Okay, I did. So it's 22,433 speeding tickets divided by 71,000, I think. 71,671 traffic violations. And notice how it goes out all of these spaces. We get all of this. So I'm going to round it to 0.313 because if I try to go outside of that, it's not going to work. So I'm going to go back here. The sample statistic here is 0.313. In percentage form, that's going to be 31.3%. So by going out the extra space on this allowed me, I didn't want to get the A in that, allowed me to get my decimal value out to the nearest tenth. So our sample statistic, so basically of all the traffic violations that were giving out that year, about 31.3% of them were speeding tickets for Dutchess County. Now, I used a way to get the standard deviation for this. It's a really long calculation. So I decided just to give you the standard deviation here. So the standard deviation is 0.0017. If I want to determine the 95% confidence interval and the margin of error, I'm just going to do what we did before. I'm looking for the 95% confidence interval. And I can do it in decimal form or I could do it in percentage. But since I changed it to a percentage, I'm going to do this as a percentage. So I'm going to do an open up. Now, my number, the N, is the large number. It's the 71,000. The margin of error is 0.0017. And the population, the mean is 31.3%. So let's go find that over here. I'm going to reset. I am looking for the 95% confidence interval. The sample size was 71,671. The sample mean was 31.3, I think, percent. I think it was, yeah, because it was 0.313, 31.3%. And I already figured this out need a decimal point, so that you wouldn't have to do the calculation to get the standard deviation. So I did that already for you. Interesting. Margin of error, 0. Confidence interval, 31.3, 31.3. Why do you think that happened? Why do you think that happened with this? This is an interesting little piece. I'm going to do a screenshot of this whole piece because I want you to see what just happened. Okay. So the reason why this happened is, I'm going to put it underneath. Did this represent I'm going to move it up. Did this represent just a sample, or was it the entire set of tickets that were given out that year? This actually included every single ticket for the year. So it was the population. Therefore, everything's going to come out exactly to the 31.3. So I thought it would be interesting for you to see one where if I did use the population, what would happen. So we get a 0 margin of error because I used the population of every single traffic violation that was given out that year and how many was speeding. Let's go back down to some of these. I got questions from several of you about what to do when you have questions that look like these. So here's this first one. A recent poll, 100 people were randomly sampled, and 95% said that they like dogs. The researchers conclude that they are 99% confident that in the population, the true percentage of people who likes dogs is between 89.4 and 100.6. So this is a 99% confidence interval. So all I'm going to do for myself is just write this next door, right down next to it in the range that I've been showing you how to write it. 89.4 for the low, 100.6 for the high. 100.6 for the high. So this is our 99% confidence interval. Then the researchers talked to their sample of 100. So this is another sample of 100 people. And they wanted to figure out what the statistic was. What is the sample statistic rounding to the 10th place? Well, if we know that this is the 99 percentile, the sample statistic would have to land in the middle of this. It would have to be the exact middle. Well, how do you get the middle of two things? Add them together and divide by 2. So I'm going to go to the Desmos calculator again, clear all that's out here, and it was, let me just go back and see what the numbers were. 89, I want to change the coloring of this so I could see it. 89.4, 100.6. So I'm going to put in here 89.4. I don't need to put a space, I forgot. Plus 100, I did it again, 0.6. And then this value, the answer needs to be divided by 2. So I need to take the 190 divided by 2, and the exact middle is 95. So the sample statistic, the exact middle here is going to be, there's something called the p-hat, which represents sample statistic. I know we haven't really used that symbol. Oops. Trying to find my p-hat. Okay, so that just means your sample statistic. Back. Equals 95. And these were in percentage, so that was the in percentage. Okay, what is the sample statistic rounded to the nearest tenth? Well, it came out exactly even, so I don't have to put the 0 because 6 and 4 got added, so 190 divided by 2. The margin of error, there's a few ways to get it. I can subtract the 2 and get the difference and then divide by 2. So what I might want to do on the calculator is try and get back to the calculator. Subtract the two values, 100 point, I did it again. Why do I keep hitting that instead? 100.6 minus 89.4. And now I'm just doing it in one shot, which I could have done earlier. And the margin of error is 5.6. So if I wanted to show you the work, I would just highlight this. And I know that this is going to equal 5.6. And it equals 5.6 percentage points. I should be able to get it up higher. Okay, so round the margin of error to the nearest tenth. Confidence interval we have, but what they're wanting here is the plus or minus. So, oops. So this is going to be a 95.5, a 95%, I mean, the plus or minus 5.6%. I just bounce that out a little so you can see it. So there's a lot to do here. Okay, so the confidence interval, 95 plus or minus 5.6%. This is another one about a recent poll, but this time they're using a 99% confidence. This was 99 also, huh? A 99% confidence interval. So I'm going to do the same thing. 99% CI. Write it in the terms that were there. 74.5% to 95.3%. That gives us the confidence interval this way. And to get the sample statistic, add these and divide by 2. So I'm looking for a p-hat. I don't want to look it up again, so Control V, and I will find out what it is. So I'm adding 74.5 and 95.3. 74.5 plus 95.3. Let me just double check if I was correct on that. 74,595.3. And so I can do it all in one time. I will put the parentheses on. Divide by 2. 84.9. 84.9. 84.9%. So here's our sample statistic. What is the margin of error? Well, the margin of error, I'm going to do the difference. I'm going to subtract the 2 and divide by 2. So for the margin of error, I'm going to go to a new line. I'm going to subtract the 2. I might as well do the parentheses. I don't have to do it later. 0.5 divide by 2. And that's a pretty big margin of error, 10.4. So the margin of error here, MOE, you need to show your work, is 10.4. And I will go back and grab it from the other side in the picture. I should have grabbed it on the other one. Confidence interval using the plus or minus. Just going to steal it from here so I don't have to retype it. And this is going to change to 89.4. 89.4, but a 10.2. And then this one's worded a little bit differently. Out of 300 people sampled, 300 had children. The researchers concluded that they were 90% confident that the population, the true percentage of people with children is between 16.2 and 23.8. So the first thing we have to do is figure out what is, I can see it already, 60 divided by 300 equals, well, if I take the zeros off, it's going to be 0.20, but just in case you don't believe me, I'll do 60 divided by 30, or 300. 60 divided by 300, and it is 0.2. So go back here. So this is 0.2, which is the same as 20%. Is this between that range? It looks like it's between that range. That looks like it's going to fall in there. And now they're saying at 95% confidence interval, we have a low of 16.2, whoops, a high of 23.8. And did they want anything else from here? They didn't even ask for the margin of error, which I can easily get because I already know this is 20. So 23.8 minus the 20, which should be right smack in the middle, would give me a 3.8 margin of error. But let's make sure, okay? So to get the margin of error, we subtract 23.8, 16.2. 23.8 minus 16.2. Let me back this up and put the parentheses on because I forgot them again. And then divide that by 2 and 3.8, just like I said. So we know that the MOE is going to equal 3.8%. So this is good to know. The MOE is 3.8%. And if we write it the way we've written the others, I would just make this 20% plus or minus 3.8%. Now, this is not the only way I could have done this in this case. Because I knew that this was 20%, I mean, I could have figured this out this way. I could have just added these two and divide by 2 and see if I still get 0.2. You have different options as long as you understand what the concept is saying to you. I just want to prove that to you. So let's go the other way. What if whoops, wrong thing. What if I did this and I took the 23.8, let me get the parentheses with it, 23.8 plus 16.2, two items, get the average, divide by 2, you're still going to get the 20 right there. So you had a couple of ways to get the mean. The mean is going to be right smack in the middle of your confidence interval. And then from the confidence interval to the end is going to be the margin of error. So let me go back to the very first picture that I showed you on here. The mean is going to be right smack in the middle of the confidence interval. The margin of error is going to be half of it. It's the distance from the mean to the end of the confidence interval. So all of these things are related. To be a 90% confidence interval, it means that 90% of all the different samples will contain the true population mean. You have the confidence interval calculator that you can use. Once you know your mean or standard deviation, you can plug it in there to get the margin of error and your confidence interval. If you know a confidence interval, you can go backwards to get the mean and get the margin of error like I did on that last one. So we have a lot here. Let's see what these questions said. The percent of people in this sample who have children is called the sample statistic. What is our sample statistic? Well, we already did all this work. I'm just going to steal a p hat from up here, which means sample statistic. Move it down here and change this to 20 for 20%. We did the work. What is the margin of error? Round to the nearest tenth. We already did this work, and we know the margin of error is 3.8, and it is rounded to the nearest tenth. And write a confidence interval. And we already did this work. Oops, I had the wrong one. So, guys, I really hope you find this helpful, and going through this might help you do those last 2 homework assignments. I'll be talking to you. Bye.